raised to the power 6 square root. 20 times 6.4 gives us 128 times 10 raised to the power 6. 128 times 10 raised to the power 6, whereby 10 raised to the power 6 will give us 1 million. Got 10 times 10 times 10, 10 in 6 places. In multiplication form will give us 1 million. So we are going to have 128 times, we have 60. And this will give us 128 million. That's 60. Then we are going to find what will be the square root of 128 million. That will give for us 113.70. But what you're looking for is velocity, meter per seconds. And that's the answer for this question. Let's consider question number 3. The gravitational force of the moon is 1/4 that of the Earth. If a body weighs 8.0 Newton on the moon, calculate its weight on the Earth. Let's start from the gravitational force of moon. Let's say force of moon, F sub, which means force of moon. F heart, which is force of heart. Okay? But the question says the gravitational force of moon, F of moon, is 1/4 that of heart. 1/4 of the force of heart. Let's put it like that. Okay? If a body weighs 8.0 Newton on moon, that is, F of moon is 8 Newton. What will now be the weight on the Earth? Simple substitution. F of the moon, that is, the force of the force of the moon is this. So let's put it where we have this. 8 is equal to 1/4 Fe. And we can say 1/4 Fe is equal to 8. It's the same thing. So that the force of the Earth will now be equal to 8 times 4. Or 4 times 8. Okay? But if you try to cross multiply, you are going to have Fe. Let's put it like this for you to understand what you are talking about. We are going to have, let's have it like this, that you are going to understand what you are talking about. We are going to have 1/4 Fe over 4 is equal to 8/1. So that force of the Earth will now be equal to 4 times 8. So, and what we are going to have is 32 Newton. So, the weight of the Earth will now be 32 Newton. Question number 4. The objects of masses 6 kg and 40 kg are separated by a distance of 0.4 meter. If the gravitational constant is 6.6 times 10 raised to the power minus 11 Newton per meter squared per kilogram squared, calculate the gravitational force of attraction between them. We are still going to pass through. We are given M1 to be equal to 60 kg. We are given M2 to be equal to 40 kg. We are given the distance between the two masses to be equal to 0.4 meter. And we are given the value of our G, which is gravitational constant, to be equal to 6.6 times 10 raised to power minus 11. 6.67 times 10 raised to power minus 11. Then the force will be equal to G M1 M2 over R squared, which is equal to 6.67 times 10 raised to the power minus 11 times 60 times 40, or divided by 0.4 squared. And what are we deriving from this? 6.67 times 10 to the power minus 11 times what will be our value for 60 times 40. 60 times 40 will give us 2,400, all divided by 0.16, because 0.4 squared will give us 0.16. And what are we having from there? We can multiply 6.67 by 2,400. 6.67 by 2,400, we are going to have 16,008, everything times 10 to the power minus 11 divided by 0.16. And mathematically, what we can do now is to divide 16,008 divided by 0.16. Then, if we have to do that, we are going to have 100050 times 10 raised to the power minus 11. Let's shift this value to the back. 1, 2, 3, 4, 5. We have 1.00050, 10 times 10. This one is minus 11 plus 5. Okay? We are going to have times 10 raised to the power minus 6. Then we are looking for force, Newton, and that's the value. But it can be 1.00. You may not even write the whole value. Okay? But you can also write the whole value. We can be 1.00 times 10 raised to the power minus 6. It is still correct. Consider a new topic right now, and that is prayer. Under this topic, the candidates are expected to know the following. Candidates should be able to recognize the SI unit of prayer, which is Pascal, and some other units. They are also expected to be able to identify prayer measuring instruments. They should be able to relate the variation of pressure to height, and they should be able to use a barometer as an altimeter. Candidates also are expected to be able to determine the relationship between pressure, depth, and density. At the same time, they should be able to apply the principle of transmission of pressure in liquids to solve problems. Finally, they should be able to determine and apply the principle of pressure in liquids. Before we go into calculation, we are going to concisely consider what pressure is all about. Pressure is defined as the perpendicular force per unit area acting on a surface. That is why we always say pressure is equal to force over area. From that definition, it's defined as the perpendicular force per unit area acting on a surface. Normally, the SI unit of pressure is Newton per meter squared. How do we get that? The unit of force is Newton. The unit of area is meter squared. If you try to take it together, we have Newton per meter squared. and that is the unit of pressure. But there is another unit of pressure called Pascal. Pascal, which is PA, 1 Pascal is equal to 1 Newton per meter squared. Another unit of pressure is Pascal. 1 Pascal is equal to 1 Newton per meter squared. Then we have a third unit of pressure, which we call bar, B-A-R. And this one has a follow. 1 bar is equal to 10 raised to power 5 Newton per meter squared. 10 raised to power 5 Newton per meter squared, which is also equivalent to 10 raised to power 5 Pascal. These are the various units of pressure. Apart from Newton per meter squared, it is also measured in